So in this program we're going to look at how to declare one-dimensional arrays and vectors, which you've already done, and then compare that to declaring two-dimensional, so rows and columns with both vectors and arrays. With this program we have the functions at the end, so you can see the function prototypes up here. You can tell these are prototypes of the function because they end with a semicolon and there's no open close brace with the enabling code. Let's take a look at main first, and then we'll go and take a look at the functions, and then also talk about how both of these are passed. So if you're declaring an array in a single dimension, it's just the type of the array. So int, float, double, character, whatever the type is. And then the valid identifier, and then you have to have the open and close square braces after the identifier. And you can declare them either by putting a number inside the open close square braces, or you can leave it empty like this. Then you can do an assignment operator, the equal sign, and then you do an open brace, and then you give all the elements separated by commas, and then the close brace, and then of course the semicolon at the end. To declare a vector, you have to have # include vector in the preprocessor directives, because the vector is a class that's part of the C standard library. And then you give it the type name, and then the type name is in the less than, greater than bracket. So it's std : vector, less than the type name float, greater than to close out the type name. Then your valid identifier. And you can just declare a vector like that without any of the rest of it in there. That would be an empty vector. Or like we talked about last time, you can give it a number of elements, or like we talked about last time, you can use the assignment operator and give it an ordered sequence separated by commas, just like we did up here with arrays. And then when you're passing an array to a function, the array won't have a size that's attached to it, so you'll have to pass a valid identifier that's associated with the array, and then you'll also need to pass the size of the array. When you're passing a vector, you can just pass the vector. The vector always has that .size function that's attached to it, so you can ask the vector how large it is once you're inside the function. So that's kind of a review from last time. Let's run the program and see what we're getting. And you can see when we're running this function that just prints out both, and we'll look at that later. It's printing out the 1 through 10 that we put in each one. So now let's take a look at how to declare an array. So when you do an array in 2 dimensions, it looks very similar to the one-dimensional array. You have to give it the valid type name, so int, float, char, whatever, the valid identifier name, in this case b, and then you still use the square brackets, but you need 2 sets of square brackets. So the first set of square brackets is the number of rows, the second set of square brackets is the number of columns. And then you can still put an assignment operator and then give it a list of values. And so since this is 2 rows, 5 columns, the first 5, so 1, 2, 3, 4, 5, is going to go in that first row, and then 6, 7, 8, 9, 10 goes in the second row. And the way both C and C++ handle 2-dimensional arrays is it's really just a sequence of sequential numbers. It really goes back to just a one-dimensional array in memory, and then you're accessing it with the rows and columns. It gets a little bit more complicated though with vectors. So let's look at how we could do a vector. So the way we're going to do a vector is to put a vector on a vector. So this looks really weird at first, but think about it. It's a vector, that's your rows, and then what's in the vector, what makes each row is another vector that has the individual values that are the columns. So it's std : vector, and then the open bracket here, so the less than sign, and then std : vector, and then the float type in between the less than and greater than signs for your internal vector, and then you're closing that sign, you're closing the greater than sign for your external vector. So this is not a single operator here at the end. This is a opening for float, closing for float, and then this greater than sign closes this internal vector. So again, two-dimensional vector is a vector of vectors. So you can go ahead and declare just an empty vector. If you did that, it'd just be a semicolon there, and the rest of that line would be gone. Or if you want to go ahead and declare some rows and some columns, we could do this several different ways. We could do a vector that had 2 rows, so we'll do open parentheses 2, comma, and then we have to put something in each of the row. So what we could put in the row would be another vector. So this is our internal vector of type float. That'll be 5 long, and we'll put 99 in there. We could do a vector that just has 2 rows and no columns, and then we could do pushbacks to get the columns. That would be the second declaration. Or we could do a vector where we go ahead and just put the numbers on it, just like we did up here. So in this case, we could do this 2 different ways. One is to do an open brace and then do another open brace and put your first set of column values, so that very first row, close the curvy brace, do a comma, open the curvy brace, do your next row, close the curvy brace, close the overall curvy brace, and semicolon. Or you can also use an assignment operator. So then running this, you can see as we're going through and printing these guys, we've got the, let's scroll back up, we've got a B that's printing out, so this would be B here. And so you can see those rows and columns that printed out. And then we printed out V2, so V2 had the 999 in all of the spaces. When we did our empty vector that just had 2 rows but no columns, our function prints out empty vectors, no columns, because it can't print it. And then you can see those last 2 vectors got the numbers 1 through 10 printed out between the 2 rows. Okay, so let's take a look at how to pass these. So we have print array, and we have it overloaded for both arrays and vectors. So notice this is just your one-dimensional, so this is the same as what you've seen before. So notice you have your type, then you have the name of the array, and then the square brackets. Remember that arrays just are passed as a pointer, so this is always going to be a pass by reference. Looking at this one, you have your vector. Vectors is a pass by value by default. If you wanted to do a pass by reference, you'd have to put that ampersand, the reference operator, in front of the vector name that you're using for the function. And then if you're going to do a 2-dimensional array, you have to at least specify the number of columns. It won't pass correctly if you don't specify the number of columns, and you can't have the number of columns be a variable. It has to be a number or a constant. So you'll notice way back up at the top of the program, we did const int n underscore calls, and we put 5 in there. So we have to have that either be a constant or we have to have it be the number 5. We can't have it be a variable. It won't be able to handle the passing of the 2-dimensional array correctly. And now it's receiving the number of rows here. And notice that you don't have to pass the number of rows with the array. Again, the array passes as a pointer, so it's always going to be a pass by reference. when you're passing the vector on the receiving end of the two-dimensional vector, you have to have the std::: vector, and then you have to tell it what kind of vector is inside, and then on the very inside you have to tell it what the type is, int, float, etc. The default is pass by value, and you'd have to again put an ampersand in there if you wanted it to be a pass by reference. Notice with the vector, it's allowing you now to use all these different vector functions, so empty, size, etc., etc. So hopefully this gives you some idea kind of the syntax with vectors and arrays, and kind of some of the similarities and differences between one-dimensional and two-dimensional arrays and vectors. Thanks for watching.